The last section in this chapter is about Le Chatelier's principle, a topic we did in intro. What is Le Chatelier's principle? It says that if a change is imposed on a system at equilibrium, the position of the equilibrium will shift in a direction that tends to reduce that change. In other words, if something is done to the reaction will shift to counteract that particular change. There are different effects or stressors on a particular system. One of the effects is concentration. The system will shift away from the added component. If a component is removed, the opposite effect occurs. So therefore, if we increase concentration of a particular reactant, then the reaction will shift towards the products. If we increase the concentration of what is a product, we'll shift towards the reactant. It's going to do the opposite. If we decrease the concentration, it's going to shift to refill that. So if we decrease the concentration of products, then the reaction will continue to move to the right. Temperature is another stressor for a reaction. K will change depending on the temperature. Now, concentration doesn't change the value of K because the reaction shifts to keep K constant. However, temperature can change the value of K. So, for example, an endothermic reaction, one where the heat energy is a reactant, the energy, if we increase the temperature, it's going to shift away from the heat term, which is on the left, towards the product side. In an exothermic reaction where energy is a product, if we heat that up, the reaction will then shift back to the left to get more reactants and thus actually reduce the value of K. Another stressor for a reaction is pressure. Now, this particular stressor is only for gases, because remember, gases are affected by temperature and pressure. Solids and liquids aren't even involved, of course, in equilibria. And it says the system will shift away from the added gaseous component. If a component is removed, the opposite effect occurs. It's similar to pressure, to concentration, pardon me. The addition of an inert gas does not affect the equilibrium position. This is often a question I see on the AP, because some people think, well, if I'm adding something, that's a stressor, it's going to change the pressure inside the system, that's going to change the equilibria. That is not the case. So if you add an inert gas, it really doesn't change the equilibrium position at all. And here's the one that you might remember from intro. Decreasing the volume shifts the equilibrium towards the side with fewer moles of gas. So the only trick you could have is, if some of the reactants are not all gases, you only need to add the coefficients that are gases and compare those. If the number of moles of gas equals on the left equals the number of moles of gas on the right in a reaction, then there's actually no shifting at all. So here's our last slide for this chapter. This is a reaction we had earlier. You notice nitrogen gas and hydrogen gas produce ammonia. And what are the different stressors that could happen? Well, we could say that I'm going to increase the concentration of hydrogen. If I increase the concentration of hydrogen, the reaction is going to shift towards the right-hand side of the equation. If I want the reaction to shift left, what might I be able to do to achieve that? Well, once at equilibrium, to shift the reaction left, I could do several things. I could increase the concentration of ammonia, that would shift it left. I could decrease the concentration of nitrogen, or decrease the concentration of hydrogen. Both of those would shift the reaction left because the reaction would react as a stressor to shift it back. Let's look at pressure. Again, notice these are all gases. If I decrease the volume of the container, then which way will the reaction shift? Well, let's take a look. On the left, there are 4 moles of gas, and on the right, there are 2 moles of gas. So if I decrease the volume of the container, it's going to shift toward fewer moles of gas. In this case, it's going to shift to the right. So these are just some examples of the effect of changing concentration or pressure on the shifting of the reaction. Now in this case, we don't know if the reaction is exothermic or endothermic, but if I said to you that I heated the reaction up and the reaction went to the right, then you could tell me that this reaction was endothermic, because obviously it's moving away from the heat term, which must thus be on the left. So these are the kinds of questions you might see about Le Chatelier's principle. Very easy, straightforward kinds of questions, excellent questions for multiple choice or for explanation questions, and I see these very frequently on the AP exam.